Imagine floating in the vastness of space, surrounded by galaxies, nebulae and stars, yet hearing nothing. What if I told you that the universe is not silent? That beyond the darkness lies a symphony of vibrations, pulses, and cosmic rhythms waiting to be heard. Today we are about to embark on a journey unlike any other, where the invisible forces of the cosmos are transformed into sound, allowing us to listen to the heartbeat of galaxies, the hum of nebulae, and the rhythmic pulses of distant stars. This is not just science, it is an experience that bridges the gap between imagination and reality, where data becomes music and the universe speaks in ways our eyes alone could never perceive. As we dive into this incredible exploration, you will discover how the sounds of space reveal secrets, patterns, and stories that have been travelling across millions of light years, waiting for us to listen. Stay with me, because by the end of this journey, you won't just understand the universe. You will feel it, you will hear it, and it will inspire you to see the cosmos in a way you've never imagined before. The universe, despite appearing vast and empty, is far from silent. Space is filled with invisible waves and vibrations that travel across unimaginable distances, from the gentle hum of interstellar gas to the dramatic pulses of neutron stars. These phenomena exist in forms that humans cannot directly perceive. Radio waves, X-rays, gravitational waves, and electromagnetic radiation carry immense information about the cosmos. Traditionally, we've relied on telescopes to convert these signals into visual images, providing snapshots of stars, galaxies, and nebulae. But this method only captures one dimension of reality. By translating these invisible vibrations into sound, we gain a profoundly new way to experience the universe, bridging the gap between abstract scientific data and human perception. When the motions of a galaxy cluster, the swirling gases of a nebula, or the rhythmic beat of a pulsar are transformed into audible sound, patterns and dynamics emerge that were otherwise hidden in the vastness of space. This approach also emphasizes the interconnectedness of cosmic events. The oscillations and reverberations of one object can influence another, creating a symphony of cosmic interaction. Humans, inherently attuned to sound, can recognize tempo, rhythm, and pitch in these celestial signals, turning complex data into something intuitive and emotionally resonant. The idea that space is alive with vibrations challenges our traditional understanding of emptiness and silence, inviting us to listen to the cosmos as a dynamic, ever-changing environment rather than a static void, revealing its rhythms and harmonies in ways that sight alone could never capture. Astronomers have developed a technique called data sonification, which transforms the invisible signals of space into audible sound, allowing us to hear the universe in a way that complements visual observation. Light waves, radio emissions, X-rays, and other forms of electromagnetic radiation travel across space, carrying information about the composition, movement, and energy of celestial objects. Normally, these signals are captured by specialized instruments like radio telescopes or space observatories and converted into visual data such as images or graphs. However, sonification takes this a step further by mapping the frequency, intensity, or timing of these waves into sound waves that humans can perceive. For instance, the varying intensity of a star's radiation might be represented as a change in pitch, while the rotation of a galaxy could be translated into a rhythmic pattern. This process allows scientists to detect subtle patterns or anomalies that might be difficult to identify visually. By listening to space, researchers can explore phenomena such as pulsars emitting precise beats, black holes producing harmonic vibrations, or nebulae resonating in complex layered tones. Data sonification also opens opportunities for creativity and accessibility, as visually impaired individuals can engage with astronomical data through sound. Furthermore, the method provides an immersive way to connect with the universe, turning abstract numerical measurements into tangible, perceptible experiences. In this way, sonification does not merely replicate what telescopes see, it reveals dimensions of the cosmos that were previously hidden, emphasizing the dynamic, vibrational nature of space itself and giving humans a new sensory connection to the celestial realm. Every galaxy and nebula in the universe carries a unique signature, a distinct pattern of energy and motion that sets it apart from every other celestial object. These signatures are not immediately visible to the human eye because they exist in forms of energy and radiation that our senses cannot naturally detect. For instance, the dense clusters of stars in a galaxy emit electromagnetic waves across multiple frequencies, while clouds of gas and dust in a nebula vibrate and oscillate in complex ways due to internal turbulence, magnetic fields, and interactions with nearby stars. By converting these signals into sound, scientists are able to assign each object its own voice, a way to experience the universe audibly. Pulsars, which are highly magnetized, rotating neutron stars, produce precise rhythmic pulses with sound that can be interpreted as beats, while the diffuse, sprawling gas of a nebula generates layered, continuous tones that shift in intensity and pitch. These sonic representations make patterns in the data easier to perceive, revealing fluctuations, rotations, and interactions that might be overlooked in visual imagery alone. Moreover, the unique tonal qualities of each celestial body highlight the diversity and complexity of the cosmos, showing that space is far from uniform or static. Through this process, we can not only analyze the physical properties of stars, nebulae, and galaxies, but also experience them in a way that is emotionally resonant, transforming abstract measurements into immersive soundscapes that reflect the individuality and dynamism of every object in the universe. This auditory perspective gives humanity a more intimate understanding of the cosmos. Sonification of space provides scientists with a powerful tool to uncover phenomena that are often hidden from visual observation. While telescopes and imaging techniques reveal the structure and composition of celestial objects, many dynamic processes in space are subtle, complex, or occur at scales that are difficult to detect visually. By converting data from electromagnetic waves, X-rays, and other cosmic signals into sound, patterns and anomalies emerge in ways that are perceptible to the human ear. For example, shock waves from supernovae, the turbulent flow of gas in nebulae, or the oscillations of a black hole's accretion disk can be translated into audible frequencies, revealing rhythmic or harmonic patterns that indicate underlying physical processes. Sonification also allows scientists to detect correlations between distant events, such as how the movement of one galaxy may affect the vibrations in a neighboring cluster, creating an interconnected map of cosmic activity. This approach makes it easier to notice irregularities, periodicities, or sudden changes that may point to previously unknown phenomena. Moreover, listening to data adds an intuitive, almost instinctive layer to analysis, complementing numerical or visual methods, and can sometimes highlight trends that sophisticated algorithms might overlook. By exploring space through sound, researchers gain a multidimensional understanding of the universe, uncovering hidden interactions, energy flows, and structures that enrich our knowledge of cosmic evolution. This technique transforms raw, abstract measurements into perceptible patterns, enabling a deeper, more nuanced exploration of the forces and dynamics shaping galaxies, nebulae, and other celestial entities across the cosmos. Hearing the universe transforms our connection with space from a purely intellectual experience into an emotional and sensory one. While images of galaxies and nebulae inspire awe, translating cosmic data into sound allows humans to perceive the rhythms and vibrations of celestial objects in a way that resonates more directly with our senses. Sound is inherently tied to human emotion and intuition, making it easier to grasp complex phenomena without specialized training. When we listen to the pulses of a neutron star or the subtle hum of a distant nebula, we sense the activity and energy of these objects on a personal level, bridging the gap between abstract science and human perception. This auditory experience also emphasizes the dynamic nature of the cosmos, showing that the universe is constantly moving, interacting, and evolving, rather than remaining static. By assigning sound to data, scientists and listeners alike can appreciate the diversity of cosmic activity. The sharp, rhythmic beats of pulsars, the layered harmonics of gas clouds, or the slow, swelling vibrations of galactic clusters, each creating a unique auditory identity. Experiencing space in this way fosters curiosity and wonder, encouraging deeper engagement with astronomy and the sciences. It also allows people to imagine the scale and complexity of cosmic events in a more intuitive way, as the subtle variations in pitch, rhythm, and intensity convey information about size, movement, and energy. Ultimately, hearing space humanizes the universe, turning distant, invisible phenomena into perceptible, meaningful experiences that inspire both scientific inquiry and emotional reflection. Sonification of space carries profound implications for both scientific research and public engagement, opening new pathways for understanding and interacting with the cosmos. By converting electromagnetic data, X-rays and other signals into sound, researchers can detect subtle patterns and anomalies that might be overlooked, through visual observation alone, enhancing their ability to study complex phenomena, such as magnetic fields, shock waves, or gas flows in galaxies and nebulae. This technique also improves accessibility, allowing visually impaired scientists and enthusiasts to explore astronomical data in ways that were previously unavailable, leveling the playing field for participation in advanced research. Beyond scientific utility, sonification has a powerful role in education and outreach, transforming abstract, numerical data into immersive experiences that are intuitive and emotionally resonant. Students and the public can listen to the rhythmic pulses of a pulsar or the harmonic vibrations of a nebula, making the universe more tangible and relatable. By bridging the gap between raw data and human perception, sound creates a multisensory understanding of space, fostering curiosity, creativity, and inspiration. This approach also encourages interdisciplinary collaboration, as musicians, artists, and educators can interpret and share these cosmic sounds, reaching audiences who might not otherwise engage with astronomy. Furthermore, turning space into sound challenges conventional ways of experiencing the universe, highlighting its dynamic and interconnected nature. It transforms scientific exploration into a deeply human experience, where discovery is not only analytical but also perceptual and emotional, expanding our capacity to comprehend, feel, and celebrate the cosmos in ways that transcend traditional observation. In conclusion, transforming space into sound allows us to experience the universe in a profoundly new way, revealing its rhythms, vibrations, and hidden patterns that were once beyond human perception. Through sonification, galaxies, nebulae, pulsars, and other celestial phenomena gain voices, creating an immersive connection between science and the human senses. This approach not only enhances research and discovery, but also bridges the gap between abstract data and emotional understanding, making the cosmos accessible, inspiring, and relatable to everyone. By listening to the universe, we are reminded of its vastness, complexity, and beauty, and we gain a deeper appreciation for our place within it.